Should be on page 46. All right, so right away we jump into a few new definitions. You're going to see a bunch of them. Just look through the next few pages. A lot of new little definitions, geometry terms that we need to get taken care of. So the first thing you're going to look at is the word bisect. So we all know what, hopefully we know anyway, what the prefix bi means. A bicycle is called that because you have two wheels. So bisect in terms of two, and then why is this not working here? It works up there, not down here. When we intersect something, you cross it. So the word suffix here, the sect, means we're going to cross something. So bisect together is when a point, segment, ray, or a line divides a segment into two. That's why we use the prefix bi, congruent segments. All right. When we have a ray, a point, line, or something bisect another segment, what that then guarantees we're going to have somewhere is a midpoint. A midpoint is the point that divides a segment into two congruent segments. Okay? All right, thanks, Christian. We gotcha. So now, using those ideas, come down here to these couple of little examples here. And there's not necessarily, you're not solving for x. We're not talking about solving for lengths. What I'm just asking you here is if segment xy, so remember all these little notations mean something. So there's no arrows here. So that's called a segment. So if segment xy, so this guy here, bisects AC, what conclusion can we draw? So what you really want to kind of think of, bisect is the fancy math word. What it means sort of in just layman terms is it cuts in half. So when you see XY cuts in half AC, what that would then mean is, let's look at AC, all right, that non-shaded one. If XY is cutting that in half, doesn't that then guarantee that segment AB, and then, actually, let me get rid of this yellow, and segment BC, doesn't those then have to end up being congruent? If that cuts it in half, AB and BC must be congruent. So in notations, we use little tick marks to indicate that. So let's put a single tick on what I have in blue and yellow. That means those are congruent. And then we're going to list these conclusions. So the first conclusion is what I just wrote right here. So use proper notation. So we're going to put AB with the segment symbol above it is congruent to BC with the segment symbol above it. So if I give you one of these quizzes where I have you grab your mouse and I have you write things down, make sure you're using these correct notations, and these are important. So AB, BC are congruent. The second thing that we can then conclude, if this blue segment is congruent to the yellow segment, which is what we said in number one, then what that would mean is B, and then using one of our vocab words that we just talked about above, B is the midpoint of segment AC. All right. Similar idea with number two. It's kind of backwards though. What I'm now giving you now is that D is the midpoint. Well, as soon as I tell you that D is the midpoint of FE, what that means is that D bisects FE. So now we're going to say that these two segments are congruent. So this segment here, the DE segment, and the FD segment, those have to be congruent to each other. So that's going to be our first conclusion. That's going to be one of the first things we've written. And then that is FE, that segment. Oh, no, sorry, not FE. A little rusty with my eraser today. So FD is congruent. That's the yellow or the blue segment has to be congruent to the yellow segments. And that's because D is the midpoint of FE. And then again, to use our definitions above, what that then means is point D, and then we use this word bisects the segment FE. All right. So midpoint and bisect, they go hand in hand. When you have one, you're going to have the other, and then just a matter of understanding how we can use those here in a little bit to solve some problems, which I think, if I remember correctly, is number 3. So those are our conclusions. So now let's go to number 3. Now we actually have some work to do. So this is now telling you that OM is x plus 8. So if I go to OM is just this interval here. You were told, also, let me point this out. Notice how there is no little symbol above OM. There's no symbol above MP. There is no symbol above OP. The way this would get read then, when there's no symbol above it, what we're looking for is the length of OM. That's how that would get read. So the length of OM, so what I have highlighted in blue, is x plus 8. Next thing you were told is that the length of MP is 2x plus 6. So if I come over here to MP, that has a length of 2x plus 6. Then you were told that OP, so think about what OP is. O is the beginning, and then all the way to P, this whole length from O to P, that has to be 44. So that's what these first 3 statements tell you. And then the question I am asking, is M the midpoint of segment OP? And don't say yes because it looks like it is. Okay, looking like it is not a reason. So just because it looks like, yeah, Mr. Pena appears to have put the M right in the middle, all right, don't do that. All right, don't be that kid. So those are not going to be something that we use as a justification. So the way we're going to be able to do this, though, what we do know is that if I add the blue interval and the yellow interval together, doesn't the blue and yellow together have to give us the total amount of 44? All right, that we can conclude. So if I set that up, so you're still going to have to set up equations as you learn these new theorems, but if I took the blue interval and the yellow interval and I add those, that should give us the entire length from starting at O all the way over to P. So then those added together would have to equal 44. Just like the quiz we took, what we've been doing now in this module, we now need to solve this equation. So combine your like terms, go through all those algebra steps that hopefully we're recalling now and getting to be pretty efficient with again. Subtract your 14. We get 3x to equal 30. Hold on. Tell me when I'm being silly here. Check your work. Notice how this is a -6 and I wrote it as a +6. So we need to correct that. Sorry. It wasn't the same answer I got earlier today. Like, what did I do wrong? So let's make this a -6. Now combine our like terms. So x and 2x is a 3x, and then now 8 and a -6 should give us 2. Now do all the algebra steps. Start isolating the variable. Divide by 3, and we get x to be a 14. The quiz, you're going to find when you look this quiz over, some of us kind of fell for this. You gave me the x value, but I was actually looking for an angle or a segment. That's also going to pop up. Notice we're not done. This is not the answer to the question. The question is this: is M the midpoint of OP? So the way we're now going to be able to figure that out, let's come over to this blue interval, x plus 8. Don't we now know that x, so I'm going to erase the x. I'm going to plug that in as 14. So the blue interval, we now know was 22 units long. Go to the yellow segment, do the exact same thing. So let your x be the 14. So I'm going to do 2 times 14 plus 6. Oh, it's a -6. My goodness. Yeah. So we got to change this one too. Sorry. If you wrote down what I wrote, make sure you have a -6 there. I copied that wrong again. This should be 28 minus 6. 28 minus 6 is 22. Notice how the blue segment and the yellow segment are identical. They are in fact congruent. So can we now say that M is in fact the midpoint of that overall segment? Yeah, because it's 44 total, 22 on this half, 22 on this half. So we would say, yes, M is the midpoint of segment OP. If these were not the same, then you would say no, and then you would just state why. All right. So those are our first. Midpoint, bisector. Basically, they both are dealing with the idea that we're going to cut a segment in half. Okay. The next one's a median. Most of you are in driver's ed right now or have recently taken it or are planning to take it this summer. You would have talked about a median in there. LaGrange Road when you go south, LaGrange Road when you go north, there's a median in the middle. When you do mean, median, mode, and range back in stats, whenever you would have been introduced to those little stats problems, the median was the middle number. So it still basically means that. All right, we're not going to change the definition of a word. Now, there's a little bit more to it with this, but the idea of it being in the middle is important. So it's a line segment drawn from any vertex of a triangle to the midpoint of the opposite side. So what I want you to do off to the side here where you have a little space, draw in your own triangle and then label our three vertices, A, B, C. Then go to A first. So this point right here, what I just told you a median is, it is a line segment drawn from any vertex of a triangle. So I'm going to have you start at A. And we're going to draw a line segment to the opposite side. So we're going to draw it over here to BC. But we want to draw it in a way so that it's right in the middle. So if you look at BC, the middle, wherever you think the middle is on yours, put a dot. And when I now connect the vertex to the middle of the opposite side, that's our median for point A anyway. Notice though it says any vertex. So let's go to point B. Same idea. We're going to go to the opposite side. So AC. So wherever you think the middle of AC is at on yours, so I'm going to put mine right here. When I connect those two from the vertex to the middle, that's our median. And then you guessed it, go to point C, same thing. The opposite side would be right about here. When I now connect those, right there. Notice how the medians all intersect at the same exact point. That's not a coincidence. It's not something we address right now, but that's something that's important that we could deal with at some point. But those are medians. All right. So now to apply that to a little problem for future, so we can do this in the future. First thing I tell you is that TW is a median. So this segment right here is a median. So apply that idea with the things that we talked about at the top of the page. What that means, doesn't that mean that W is the midpoint of SV? So if this is directly in the middle, can't we now conclude that, let's use some notations, that SW, put a single tick mark there, doesn't that have to be congruent to WV? If W is in the middle, then it just cut those sides into half. Those have to be congruent. So we can do that right away. Then I tell you that ST, the length of ST is X plus 4. So ST is here. So we'll call this X plus 40. The length of SW, so right here is SW. That length is 2x plus 30. And then WV, so from here to here, is 5x minus 6. To get this started, the reason we mark these with tick marks will allow us to now get this started. By putting the tick marks here, aren't we saying that this length right here and this length right here, aren't they congruent to each other? Well, we know what both of those are. So we're going to take that 2x plus 30 and set it equal to the 5x minus 6. They have to be congruent to each other. That's where we now get our equation. Solve that. So we'll get 30 equals 3x minus a 6. And screw this one up. Yeah, and then add 6 over. Divide everything by 3. 36 divided by 3 should give us 12. Don't circle it, think you're done. We all want all 3 of these sides. Now we actually want to know what are these lengths. So the first one we're going to do is SW. So if I now want SW, what SW was defined to be was twice x plus 30. We now know what x is, so I'm going to erase the x, and I'm going to replace that with the x value that we just found it to equal. So that's what? 24 and 30 make 54. Think about what that means in terms of my diagram now. If I now go to my diagram, I'm going to erase the expression. I don't need that anymore. Don't I now know that this has a length of 54? WV, we could do it the algebra way, but don't I know that this has to be 54 as well then? We don't have to worry about substituting in anymore. We know that WV, since those were congruent, that must also be 54. So we can now, instead of this, just write in the length of 54. We now know that. The last missing piece is ST. ST is x plus a 40. Instead of using the x plus a 40, I can now get rid of the x and replace it with what we had found x to equal, which is a 12. And that is 52. Okay. So good brain teasers a little bit. Problem solving, putting a lot of ideas together, a lot of steps here. All right. So that's how we can use our median. The next word, you are familiar with this one already. Perpendicular, we should be familiar with. So it can happen to lines, rays, or segments as long as they intersect and form right angles. Recall, right angles have a degree measure of 90 degrees. The reason we talk about this in geometry, we don't want to assume anything. What this question is asking you is, are we able to assume anything is a perpendicular or set of perpendicular lines? You're going to say no. We never want to assume that. It applies to this question. So if I go to example number 5, if I ask you, we'll talk about what this means in a minute, which angles can you conclude are right angles? There's a lot of people who are going to look at this and say this angle right here and this angle right here because they look like right angles. Just because they look like right angles, you're not going to say they are right angles. So we don't want to assume that these two guys right here are right angles. If we read what I gave you, though, I tell you that line EF, or segment EF, so here is, or sorry, EH, here's EH, is perpendicular to segment HG. So it is those two lines that are perpendicular to each other. And because they are perpendicular to each other, those are the ones that are forming that 90-degree angle. So if you remember, the way we write that in geometry is with a little square. So if I take these two yellows, and as best I can, don't judge my artistic work, it's already bad, draw in a little square connecting these two segments up here. That's where our 90-degree angle is. So the only angle that we can say is a 90-degree angle is angle, so use your little angle notation, is angle EHG, the one that's connecting those two yellow line segments. That's the only angle we know for sure are 90 degrees. All right, with that statement only. Well, now we gotta think if I can make this. Yeah, we want to be able to do that. All right. So now number 6. This one will make you think a little bit. It says given KJ and KM to be perpendicular. So let's look at those two things here. So KM, KJ are perpendicular to each other. So now we're not assuming, we know that we can draw our little square there to show a 90-degree angle between those two. Then I tell you that JKO, so JKO is this angle right here, is 4 times larger than MKO. Uh-oh, I don't want that. So then this angle. So notice how there's 2 different angles that make up that full 90-degree angle. The yellow one is 4 times bigger than the blue one. And then the question is, what is the measure of JKO? So here's what this is really saying. Let's say this little angle was 10. So don't write this, but let's say this angle was 10. If the bigger angle is 4 times larger, wouldn't this angle then have to be 40? 4 times bigger than 10. All right. Let me give you another set of numbers. Let's say I tell you that this was 20. Then if this is 4 times larger, wouldn't this have to be 80? Right? It's 4 times bigger. Well, what we don't know, and we don't want to necessarily guess and check because some are easier than others, we don't know what either one of those are. So instead of assigning some random number that I'm making up, we don't know it, and that's what a variable is used for. So mark the blue one X. How can I now define the yellow one? So when I put 10, we all knew it was 40. When I put 20, you all knew it was 80. Now that I put X, we all should know that it's going to be what? Do the same thing that you did when I gave you a 10 and when I gave you a 20. Good. Thanks, Jake. Whatever I've been giving you here, aren't you then just taking that value and multiplying it by 4? Okay, so that's how it looks with some algebra there. Then we know that don't the blue and the yellow have to add up to be the full 90 degrees? So what that allows us to do is say, let's take the yellow angle, let's add it to the blue angle. Those 2 angles together make up the 90-degree angle that you were told existed at the beginning of the problem. And then voila, there's our equation. We can now get started to solve this. So 5x equals 90. 90 divided by 5, 18. Sometimes, again, that's your answer. Actually, that is this answer, right? I guess. But just make sure we're solving for the right angle. So this blue angle is 18. Now I'm not making it up. If I want to know what the yellow angle is, it's 4 times 18. And we now know that that has to be 72 degrees. So this angle would be 72 degrees. Okay. All right. Next definition, an altitude. So an altitude is another line segment drawn from any vertex of a triangle. So in terms of what we've done already today, where this is similar, we did a median, correct? So don't draw this in. But one thing we said we could do is to go to a vertex, so over here, and draw a line to the opposite side in the middle. That's a median though. So this starts out with the same idea. I'm going to go to any vertex in my triangle, so from any vertex, such that it is perpendicular to the opposite side. Actually, let me have you start with, I'm going to name these angles 1, 2, and 3. I want you to start with angle 1, because it's the easiest one to see. We're going to take this here. We're still going to draw it to the opposite side, okay? But we want to draw it in a way that it's going to be perpendicular to the other side. So we've done a median. So again, don't write this down right now. Here's the middle of this triangle. This is what a median would look like. Is there any chance that the 2 angles right here and here are 90 degrees? No, and that's what has to happen if it's perpendicular. So we don't want to draw that in. That would be you drawing in your median. So don't draw that. The only way I can create this and make a 90-degree angle is go from 1, and then all you're going to do is drop straight down. Notice how that now forms a nice T right here. That would give us a 90-degree angle. So go straight down from that first angle, and we get a 90-degree angle. However, we should be able to draw this from any vertex. So go to this vertex here. Try to draw a line to the opposite side, so this side here, in a way that when it hits the other side, it's going to form a 90-degree angle with that side. So if I draw in this here, does this appear to be a 90-degree angle right there? Okay, I would say no. Like if you had a protractor in your hand, we measured that, not a 90-degree angle. We want to draw in a way that it's 90 degrees. So for me, to get this to be 90, we probably have to go way up here to now kind of make this start to look like a nice T. If it's one of the ones where I have you grab your mouse on the computer and try to draw it in like I've had you do numerous times, there'd be a little bit of a leeway, but it should be pretty close to being a 90-degree angle right here. And then the last one, let's come down to this vertex. This one isn't as bad. Probably something like this, where I can form a 90-degree angle with that other side. So there's always 3 altitudes, just as there's always going to be 3 medians. Next one. In terms of labeling these, call this angle 1 and draw in your altitude. So go to the other side from angle 1, the 90-degree angle, and draw a line that's perpendicular to the opposite side. All right, so hopefully, and again, you'd have a little bit of an error here. We wouldn't grade too harshly if we had you draw this in. Probably in order to make it a perpendicular line, needs to go up something like this to make a 90-degree angle. Now, where this one gets a little tricky is angle 2. Let's do angle 2 first. So now try to draw a line that goes to the opposite side so that it's perpendicular to the opposite side. Okay, anybody want to offer a little insight into how that could happen, if at all? How could we do that? So draw a line from angle 2 to the opposite side so that when it hits the opposite side, you form a 90-degree angle. Anybody know what's happening with? Go ahead, Jake. Good, perfect. This side here is your altitude. So he said make a line on top of it. Even that's unnecessary. Just know that the line that he's talking about, that is your altitude. So sometimes the side of your triangle is the altitude of the triangle at the same time. Yeah, good, Jake. Thank you. So if I do letter 3 or number 3 here, isn't that going to be the same thing? If I've got to draw it to the opposite side, the only way I'm going to get a 90-degree angle, just follow the side of the triangle. And when we do that, there's our 90-degree angle just like that. So in this case, 2 of the sides end up being our altitude. All right, so weird stuff there. All right, speaking of weird stuff, let's finish with this guy. Call this angle 1. Go ahead and do that one. That one should be nice. So go to the opposite side, form a 90-degree angle. And then this one should be nice. So no tricks. Should look something like this. Where this one gets weird now, let's say I have you do angle, let's do angle 2, we'll call this one. Let's try that one first. If I now start trying to draw in lines to the opposite side, so let's say I go here, any chance that's a 90-degree angle? No, if I come over here, or way over there, any chance any of those are going to end up being a 90-degree angle? No. All right. So the one thing I didn't read yet when we ran over this is this, or the extension of the opposite side. So what you can do, and what we need to do in this case, is go to this bottom side And we're just going to extend this. I'm going to make a little dotted line that would extend this if we were to extend that side. So where this median is going to get drawn is right here. That's, or not median, the altitude. That's where that altitude would get drawn in. The reason the altitude is important and the reason we would do this as an extension is a lot of times the altitude of a triangle helps us find our height. And then we could definitely use the height for things like area and volumes, things like that. All right. So then that would be this one. And then our third one would be pretty much the same thing. Like if I had to go to this third one, you would extend it over here to form this 90 degree. All right, so that's an altitude. Okay, and then as usual, Mr. Krubwitz, we are one problem short of first period again, somehow, even though the minutes are the same. So it always happens. So you have less than a minute. Like I said, no homework. We weren't going to get through it. The next page then is putting a lot of these together into some problems, kind of the crux of what we want to get at. So we'll do these tomorrow, and then we'll get you some homework tomorrow night. Okay, so you're free tonight. Have some fun. Enjoy the snow if you like snow, and we'll see you guys tomorrow. All right. All right. Take it easy. Bye. I agree, Justin. I do not like the snow. All right. Let me stop this.